All right. Hello. I wanted to ask you about problem, this very simple elementary school math problem. But I guess my concern has been some of the reactions that seem to be very repeatable. I run into this a lot when I'm looking at Facebook posts where mathematics problems are posted. I see a certain segment of people. I don't know what to call them other than it seems like they're seeking herd immunity. Um, for example, there's a recent problem I've seen on Facebook: 5 plus 4 times 2 minus 3. A very simple elementary school level mixed operations problem. And a lot of people are getting the correct answer of 10. They understand that you multiply 4 times 2, you get 8. You add to the 5, subtract 3, you get 10. But then there's a lot of people out there that are getting 15 because they're basically, blindly solving left to right. Um, and when you mention to anyone that, hey, 15 is, not really the correct answer, and you say like, I'm sorry you missed the lesson on the order of operations, but people will say, well, that's not how I learned it. And apparently, by looking at all the answers, I'm not the only one. I'll see answers like that, and it's a little bit concerning. But then again, it seems to be very repeatable. A lot of people do that.
Yeah, absolutely. And it's really interesting how that happens. You do see that pattern where folks kind of look around and say, well, if other people are getting the same answer as me, even if it's the wrong one, maybe there's some truth to it. And like you said, it's almost like a herd mentality or herd immunity kind of thing where they think if enough of us say it, maybe we're right. But as you know, math doesn't really work that way. There's a correct answer and there's a reason for it. And it's kind of a common thing to see people just lean on that. But it is interesting and a little concerning, but it's also kind of human nature. So yeah, definitely a good topic to dive into.
Yeah, and it seems like there's different levels of this too, of this resistance, or there's different levels of this denial, of like denial of reality. I'm not sure what else to call it. Um, for one example, and I'm not going to name names here, of course, but when someone mentions this, I've seen someone asked about the order of operations, and they're like, "Well, I'm not sure about that. I was born in 1948 in the Midwest. I don't remember this method. I'm just doing what seems logical to me now. Start at the beginning and work through." Now, at least that seems like somebody who is thinking, maybe I'm not 100% right. In other cases, I'll have people say things like, well, I didn't learn the new math. I learned the old school way, and the old school way was to go left to right. Some people are a little more forceful in their arguing.
Yeah, absolutely. There's definitely a range of how people react. And like you said, some folks are kind of open to the idea like, hey, maybe I just never learned it this way, or maybe this is something that I didn't encounter. And then others are a bit more forceful and they say, nope, this is the old school way. This is the right way, even if it's not actually historically accurate. So yeah, you do get that range of reactions, and some people are a little more open minded and others are a bit more stubborn, but it's definitely a pattern you see a lot.
Yeah, and it seems like whenever somebody makes a claim like that, this old school versus new school math argument, as if somehow old school uh, taught you incorrectly back in the day, it seems like other people will begin chiming in and they'll go, you know what? I learned that way too. I learned that the answer was 15. It seems like it almost is like a snowball effect, I would think, in these forums. It's like a phenomenon of some kind. It seems like people start to gather, and it's almost like they're looking for herd immunity. I saw, on this one example with this problem, someone chimed in and said, when will many people understand that not every school system in the entire world taught the order of operations?
Yeah, exactly. It's almost like a little echo chamber effect, right? Once a few people start saying, well, this is how we did it, you get others who either genuinely misremember or just kind of want to fit in and say, yeah, I think I learned it that way too. And it just amplifies the whole thing. So it's definitely a bit of a social phenomenon. And people, they kind of want to feel validated and they want to feel like they weren't caught incorrectly. So they'll grab onto that idea that maybe other people also learned it the same way. But yeah, it's kind of a snowball effect. It is really interesting to see it happen over and over again in these kinds of discussions.
Yeah, and I don't know. Sometimes I wonder. I think people remember bits and pieces, perhaps, and they're misremembering things. I see people a lot of times. There are the people out there who seem to think that solving left to right was somehow a thing, and you ignored the order of operations. Then there's the other people out there who they'll bring up PEMDAS or BODMAS. They'll bring up one of the acronyms, but then they think it's a six-step checklist. They'll say things like, "Well, wait, you solve addition before subtraction, because the A comes before the S." And then I see things with, the people that solve left to right. They'll bring up things like, well, I was taught to read a book. I was taught to read sentences from left to right. So I was also taught to solve math left to right.
Yeah, exactly. It's like a mix of partial memories and just kind of logical leaps people make. Like you said, some people treat the acronym PEMDAS almost like it's this strict sequence instead of just a guideline for grouping operations. And then others are like, well, if I read left to right, then of course I should solve math left to right. So it's kind of this blend of misunderstanding and just a little bit of mixing up the logic. And it's totally human, but yeah, you see that all the time. And it's just one of those things that people kind of latch up whatever explanation makes sense to them, even if it's not actually how the math rules were laid out. So yeah, it's definitely a very common pattern.
So I'm wondering, I think maybe with a lot of people, maybe especially a lot of older people, they might be used to balancing their checkbook. They're maybe used to adding numbers, subtracting numbers in their checkbook registry, but maybe they're not as familiar with mixed operations.
Yeah, I think that's a really good point. It's kind of like when you're just doing basic arithmetic day to day, like adding and subtracting in a checkbook, you're not really dealing with a lot of these mixed operations. So maybe for some folks, it just hasn't been something they've had to think about in years. And so when they see it again, it's just not second nature. So yeah, you're probably right. It's just a matter of what people are used to doing every day. And that plays into how they approach a problem like this.
Yeah, and one of the other things I'll see pop up a lot, and it seems to be a real common mythology, is people will say things like, "Well, look, there's no brackets around the 4 times 2. There's no parentheses around the 4 times 2." And when I was in school, if you didn't have parentheses around the multiplication, you just solved left to right. And I'm thinking that may be a partial memory of something that perhaps they were taught years ago. I think there was a time that when you saw multiplication like that, teachers may have instructed them, go ahead, put parentheses around it, even though they're redundant. Excuse me, even though, even though they're redundant and not necessary. But perhaps they were told to put them around there. But I want to get your take on this. But um, some people think that if you don't have those parentheses or brackets, you just toss out the order of operations and solve left to right.
Yeah, you're absolutely right. It's like there's this lingering memory that if you don't see parentheses, it must mean you're supposed to just go left to right. And I think you're onto something. It might be that at some point teachers did say, hey, if this is confusing, just put parentheses around the multiplication step so you remember to do it first. And over time, people might have kind of misremembered that as a rule instead of just a helpful hint. So yeah, it's one of those things where it's just kind of a partial memory turned into a myth. And people think, well, there's no brackets. I just do it left to right.
Yeah,
Yeah,
yeah.
yeah, it's definitely one of those things where a little piece of classroom advice just kind of turned into a whole belief system for some people. So it's really interesting to see how that plays out. Thanks for bringing that up.
So I'm wondering, I'm kind of curious. We're talking about echo chambers, and it just came to mind. Would you consider this Chat GPT conversation an echo chamber for myself?
That's a really interesting question. I mean, I think of our conversation more as just a friendly back and forth where you're bringing up ideas and I'm just kind of reflecting them back. So I wouldn't necessarily call it an echo chamber because we're really just exploring your thoughts and experiences. but it's definitely a place for you to bounce ideas around, and I'm here to kind of be that sounding board. So I think it's a little different, but it's a really neat question.
Yeah, I think, really where my concern really is, my concern is really more with the truth, on what the real truth is, even down to something as simple as a fourth or fifth grade elementary school math problem. 5 plus 4 times 2 minus 3 is not higher math. It's fairly simple. And I guess when I see a lot of incorrect answers, and then I start seeing this echo chamber forming in the comments where people start to say, "Yeah, I was taught the old way too, and I got 15," or "I was taught back in the 1960s, and we were taught to solve left to right." I guess when I start seeing that, I get concerned because there's the herd mentality begins to form, and I don't know if there's really an answer to it. It just seems to be some part of human nature that there's always going to be people who believe they were more effective than what they really were.
Yeah, I think you're absolutely right. It's definitely a bit of human nature to kind of form these little groups where people reinforce each other. And like you said, even though it's a really simple math problem, it's more about just how people remember things and how they want to kind of stand by what they think is true. And I totally get your concern because it does kind of muddy the waters of what the actual truth is. But yeah, I think it's just one of those things we have to accept that people will do. And all you can do is keep putting the correct information out there and hope that eventually it sinks in for some folks.
Yeah, that sounds good. So I'd like to end this conversation and just get your explanation, for anyone that's listening, for what is the solution to 5 plus 4 times 2 minus 3?
Absolutely. Happy to wrap it up with a clear explanation. So, for the problem 5 plus 4 times 2 minus 3, the order of operations tells us to do the multiplication first. That means 4 times 2 is 8. Then we add 5 plus 8 to get 13. And then we subtract 3 to get 10. So, the final correct answer is 10. And that's just following the order of operations. And that's how we get there.
All right. Well, I thank you for your time, and hopefully we can discuss more of these topics in the future. I don't want to say uh, difficult topics. I hate to use the word difficult on a simple problem, but hopefully we can discuss some of this more in the future.
Absolutely. I'd be more than happy to chat again anytime. And yeah, it's not really about difficulty. It's just about exploring these interesting little quirks. So thanks for the great conversation, and we'll talk again soon.
All right. Thank you.
You're very welcome. Take care and talk to you next time.